Hey, everybody, we're back again for episode two of the Neural Audio Podcast. I'm here with Andrew Fife and Christian Steinmetz, our co-hosts. And yeah, we're welcoming you back. Just want to give you a quick reminder at the start. We're going to continue this discussion on our audio programmer community on Discord. If you want to join us at theaudioprogrammer.com/community. So, Christian, you're in a different location today.
Yep, I'm back in London now, continuing my PhD work here at Queen Mary, University of London. So, yeah, I was spending the summer in Boston, and good to be back in London, just in time for the rain, as usual.
That's great. We were talking a little bit before the podcast about just what being in your final year of your PhD is like, and I was very curious to hear more about that. So, can you tell us a little bit more about your day-to-day, uh, a day in the life of Christian as a final year PhD student?
Yeah, it definitely has its ups and downs as far as, the stress and as it is often the case, you have large periods of kind of you're just working along and going hard and deep into some problem. But then there's always those like crunch time moments where you need to be ready to present things and get those results at some deadline. And so actually for me recently, I just had what's called like my stage two progression, which is like the final kind of checkpoint before you submit your thesis or like start writing your thesis basically. So it's like explaining to a panel like everything you've done so far and proposing a plan for like what's the rest of the PhD going to be and how are you going to sell this as a full complete work. So I kind of had to scramble to get all of my works together in order to try to make a coherent story, which is another challenge in itself because the PhD is kind of like a branching tree, and you kind of have to figure out how all the branches are related, and you can do it's actually interesting because there's usually more than one way to outline it, and you have to kind of pick which story you're going to go with. So the good news is that my panel was successful and I'm ready to move on to the next stage. So really just closing out the last few projects I have and hopefully finishing up the PhD.
That's cool. And
Yeah.
how did you decide what you were going to study?
Yeah, so I think it's also quite common in the PhD that you kind of just start out doing, whatever you're most interested in at the beginning, but it's really difficult to know like 3, 4 years in the future when you look back, like how are those things going to actually connect? Like it's very rare that you like have that vision of the full structure at the beginning. You usually just have some little piece of it and you kind of follow that and see where it goes. So for me, I think what I've kind of ended up framing it as is kind of at least two main kind of aspects of the PhD, which is about one, designing audio effects using neural networks and machine learning, but also this other side of it of controlling audio effects with machine learning. So kind of one is like in the controlling case, you've been given audio effects already or VSTs or any type of device, and you want to use machine learning to like intelligently control that. So you're only like predicting parameters or making actions and stuff like that with DSP. And so that has interesting questions, and we had to go really far into the research to like learn how to facilitate that in machine learning. And then yeah, the other side of like creating could be like neural audio effects, virtual analog audio, could be new types of ways to process audio effect removal, for example. We just had to work about that. So it's kind of those two different branches is how I framed a lot of my work.
Yeah, I can totally relate, Christian, to that. Having, been on the tail end of my PhD for a while now, like just been working on the thesis. I think, a lot of it is, is what you just said, like trying to frame it in the way that you want, from like a huge tree of like possibilities. Um, you know, like you said, it kind of starts as a seed and then kind of grows and goes in multiple directions. And it's about like at the end, it's like almost like trying to rein all that in and then trying to construct a narrative, like a cohesive narrative, like across the whole body of research, which is a challenge. I mean, I definitely found it challenging myself. Like, a lot of having to rewrite parts of. I don't know how you approached the written parts of your PhD, Christian, but like I've sort of been doing bits along the way, but then just the thread of the research ends up changing, like, as you go along, and you have to kind of like rewrite parts and like, things become more mature or some things go out of date maybe in the literature and you have to kind of revisit that as well. Um, it's a definitely quite a challenge. This that last hurdle of like finalizing the thesis, I think is yeah, it's tough but rewarding, I'm sure.
Definitely.
So is it more self-guided? So where does your is it your supervisor, project supervisor? Is that what the technical name is?
Yeah, advisor. Yeah.
Yeah, advisor. So is it more of a self-guided type of journey? And where does your advisor come in and help you uh, and kind of tag along? What's that relationship like?
Yeah, I mean, I think it depends a lot on kind of the dynamic between the PhD and the advisor as well. So I've heard like a lot of different variations of that. I think for people in our group, we tend to be like, I think at C4DM, Center for Digital Music at Queen Mary in general, people are relatively autonomous in their projects. So we often kind of say like a PhD is actually kind of like running your own startup in some sense because you're fully in control, like you're kind of fully responsible for like what you're going to do. You have to come up with the project proposal. You have to convince everyone else to, get on board with that, and then you need to be the one that kind of delivers the results and keeps pushing it forward. No one is going to tell you like you should research that or go follow this. They might give you ideas or help you brainstorm or like narrow down the topics, but a lot of it really requires on you being very proactive and kind of setting out, taking a stance on like what do you think is interesting, where should this go. And I think that's obviously really challenging, but it's also super rewarding because you kind of get full ownership over your direction of the project and the path that it takes.
I was gonna segue a little bit on that for a second, because you've done quite a few internships. So if I remember correctly, you've done internships at Adobe, Meta, Tape.it, right?
Mm-hmm.
And I think a few others, right? So I was curious because people always ask us this in the community about internships, how they work. You obviously got a successful formula with being able to obtain them. So have these been facilitated through the university, or has this been done independently by you? And what is your strategy for doing that? How do you actually handle that?
Mm-hmm. Yeah, so in general, the university doesn't directly facilitate that, so they're not going to like come to you and be like, "Here's a bunch of internships to do." So it's still really much on the student to figure out what are the opportunities that make sense and to go through that process of, uh, you know, interviewing and all of that. So yeah, a lot of that is was like just my interest in trying to have impact in product or in industry somewhere with the research, because for people that work in kind of this similar area of audio effects or intelligent music production and things like that, um, our research is relatively applied, I would say, right? So like the ultimate goal of any of our research is generally not theoretical results, but actually like proposing a system that actually would eventually work in the real world and impact users. So as a singular PhD student, you can do things like open source your code on GitHub, which is great, and I'd recommend everyone to do that. But I also found like throughout, early on in my career that like it's very difficult to be both the researcher, DSP developer, C++ developer, marketing, UI design, like all of that yourself, right? So I found that like it was just too difficult to do all of that and really have big impact, like get your product in front of a lot of people. So internships, I think, are, one benefit of them is like they do give you a way to, contribute and focus on the research, but do it in a place in which other people will be there to support and bring that thing into the real world, if you can deliver on the research side of it.
What's the application like? Did you always go the official route? Just go to the jobs page, submit your CV there, and just cross your fingers and hope?
At the beginning, yes. So I started there for sure, and like there were a few years. Like I remember, I think the year that I remember that was the most intense was probably like maybe the year I was doing my master's thesis. I was looking for internship, and I think I applied to like upwards of 60 different internships for that particular summer, and I only got one offer out of all of those. Um, and one offer that was good. So I took, and that was at Bose Research. So I took that. But yeah, I was working like really hard, just basically cold applying to all these places because it was still very early in my research career. So I didn't have like a lot of connections yet. But based on that, I was able to um, get some experience, just do something, even if it wasn't exactly what I was interested in. I was really just saying, okay, where can I do audio, DSP, machine learning, anything related to that, I will work on. If it's related to research, basically. Um, and so, yeah, I just kind of followed that and was able to get some experience. But as I've kind of gone on in my career and like had more opportunities to do internships and put my work out there, then for sure the opportunities flipped the other way and people were asking me to come work with them and stuff like that. And definitely my recommendation is like put your work out there, get some level of recognition, or do contribute to the open source community, things like that. And pick a project to work on that not many other people have worked on yet, so you kind of stand out, and people will start coming to you because they're like, oh, this is the person that knows how to do XYZ thing and we're interested in doing that here, so we want to hire them to do an internship. And that's kind of what happened to me in a few cases. And obviously having a foot in the door of like knowing someone at a company is in my opinion like really what you should be aiming to do, because that's how you really get through a lot of these processes. Otherwise it's like totally random and just people filtering through resumes like the people probably are aware of. But yeah.
Hmm. Yeah, interesting. Do you remember specifically what it was about your application that stood out the most?
I've been told by like a few people that I worked interned with early on that like basically my website was the major thing that convinced them to take a chance on working with me, because I had just done a bunch of projects of just things I was interested in. It wasn't even anything necessarily particularly special, but just like putting a lot of effort into like documenting everything, making it look good, open sourcing code, and just making it look like you're doing something. Um, yeah, and obviously you can very easily make a free website, host it on any of these platforms or GitHub pages and stuff like that. So I'm 100%, I believe that anyone working in software or research should have a website, in my opinion. Yeah.
That's awesome. So the work that you were doing inside these internships, how does that work in terms of your intersection between you're still a student? Uh, I imagine that you're working that internship to gain experience, but also to try to leverage some of that back into your academic studies. But I would imagine that the company wants to make a product. They may not necessarily want you to talk about the things that they're working on that they haven't revealed yet. So how does that work?
Yeah, I think there's a few things to mention there. I mean, one is from a perspective of a PhD student, I think alignment between the topic of the research and your PhD topic is really important. So you can always do some people do it like they just go work on a totally different topic in an internship just to maybe like clear their head or get away from their PhD work, which is can be good in some cases. But I think the real synergy happens when you kind of like can find a company that is interested in the same topic as your PhD research, because then you'll be advancing your own thesis while doing work at the company. There obviously is the bureaucracy of like, okay, working out the IP, figuring out between the university, between the company. I mean, and different universities have different processes for doing that. But I would say it's definitely worth the effort to go through that process and figure it out. For example, like the case with Tape.it, like we had to work 6 months to a year before the work could actually begin just to negotiate, the IP and the contract and things like that between all the parties. So it can be difficult, but if you are invested in it and the company is invested in working with you, there's definitely a feasible way to make it happen. And the great thing there is too that you can also negotiate it so that, for example, there is the means to publish, for example, because we're going to be publishing our paper at AES about the research that I did there. So even though it's going towards a commercial application, we're able to contribute back knowledge to the general research community in an open way, which I think is really important for consideration for PhD students also.
Amazing.
Yeah, and I think also like we've started to see quite a lot of that happening with other companies as well. Like even like isotopes. I think recently I'd published quite a few papers at AES, and I can't remember the other conference. But yeah,
FX.
like yeah, was it DAFX maybe? Yeah.
Mm-hmm.
They published some papers there, whilst also integrating like that work into their commercial plugins, which is yeah, it's interesting and it's great to see like more and more people are kind of finding, like you said, Christian, that like kind of balance or finding that way to kind of still contribute, research to the community and to the open source community and to academia in a way, but also able to contribute in industry and to like these sort of commercial projects as well.
Yeah, and that seems to have been a switch in the industry as a whole, right? That seems like I remember when I went to Goldsmiths University for my bachelor's that there was a very big divergence in terms of the things that we were studying, which are actually some of the things that are coming out now, and the things that were in the industry. And it was kind of known that the industry was this slow moving beast that just takes forever to catch on to the things that are happening in academia. But now, especially with these advancements, it feels like things have really conglomerated, and now industry is searching to be on the bleeding edge of what's happening. So tell us a little bit more about this paper that you're publishing in partnership with Tape.it.
Yeah, definitely. So this was a project that I was working on as part of my PhD, and um, so just to say a little bit about Tape.it, it's basically a small startup, of musicians, people that want to make tools for musicians, basically, and they already have an existing iOS app for songwriting, so like making recordings on your phone, kind of like voice memos, but for songwriters essentially, and having some AI features and automatic organization and high quality recording and things like that. And one of the things that we were interested in moving into was, yeah, more about enhancing audio quality. And so this particular place we decided to start was with noise reduction, which is kind of like one of the most basic things you might want to do to enhance a recording. And as I'm sure like a lot of other people have seen, there's been a lot of space kind of in the speech enhancement area, right? So you have like players like Adobe, which has their like enhance for speech, which has a ton of users. There's also Descript, and they have their enhancement as well. And what we kind of saw looking at that from our perspective is those kind of products are super cool, but none of them work for music currently, right? So like if you put in music into a speech enhancement model, it'll either do nothing or it will actually sometimes turn your instrument into a voice sound, a thing that sounds like a voice. And there were some interesting when Adobe Podcast first came out, there were some really cool like tweets that I saw of people like putting guitar riffs into Adobe Podcast, and you'll hear it like turn it almost into like a kind of like singing kind of thing because it converts it into a voice, because that model has just been trained basically to synthesize voices more or less. But yeah, so we were kind of saying from the music perspective, how could we build something that would just try to elevate the quality a little bit of these recordings? And what we decided to do there was also take into account a few other considerations. Like one, we wanted it to be very efficient, so we could like run it on device, right? So we could have it like on an iPhone and actually denoise locally, for example, or potentially in the future work in a DAW and something like that, which these other existing big models are like really not good at. They need a big GPU, you need a server farm and everything to run them. So that was one consideration. And the other one I think that was most important to me was about the artifacts, because even these very powerful deep learning models that can kind of seem to extract speech from super noisy conditions in a really impressive way, they would always add artifacts even to recordings that have just like a little bit of noise in them. And we were kind of targeting, musicians or audio producers that are like super focused on quality, right? Like they care so much about the details of the sound. They want high sample rates. They want, minimal artifacts, like all of these like classic things that an audio engineer is thinking about, like myself included. And when you look at these other like speech enhancement models, they're focused just very much on a different application of like speech, where it's like still like lower sampling rates and just speech. So we were saying, okay, how could we build a system that seems to solve all of these like impossible problems, right? And how this ends up being tied back to my PhD research is we were then thinking, well, there are already some really powerful tools for audio enhancement. Like, for example, something like Isotope RX has a lot of like recovery tools, like their spectral recovery and spectral denoise and stuff like that, that are all based on traditional DSP. And, today there are like thousands of audio engineers that are using that kind of software to enhance, audio that's going into like a professional context, right? Um, and so we were saying that's really cool, but you need to be an expert to use those tools to like get a good result, right? You can't just have anybody automatically improve the recording. So we said on this kind of application that I was saying before, like machine learning models, but ones that can control DSP, how could we enable that? And so the whole idea behind our project is to design and have some DSP based, signal noise reduction tools, and then train a machine learning model in a very specialized way to learn to control those to denoise or enhance those recordings. And in our paper, we explain kind of all the details of how we made that happen. But while it kind of seems at the beginning very simple, there turns out to be a ton of complications in like how you actually connect DSP to machine learning models. Because the thing is that it's actually already much easier just to build a giant neural network and train it to do whatever you want, because we have like tooling for that. But when it comes to like methods and techniques for integrating the DSP, there are some out there, but there's like a lot less clarity on like how to do it. So our paper kind of proposes one way to do it and shows how we can get it to work really well on this kind of noise reduction case. And I think one of the coolest results is that while we compare against some of these big deep learning models to do noise reduction for music, we find that we often perform equally well, and in some cases even outperform them when they're kind of these tricky scenarios. So for example, like we have like one jazz ensemble that's playing, and there's this like classic problem of like the brushes on the drum, but also some noise because it's an older recording. So can you remove the noise without disturbing this like very sensitive, like the brushes on the snare drum? And our recording or our method does quite a bit better on that than the deep learning methods, because the deep learning method tries to do too much and actually kind of harm the audio. So yeah, that's kind of our main idea with this, and it's currently available now for anyone to try out. So we're kind of putting it out there just for anyone to try, and you can try it at tape.it/denoiser. And yeah, we're really interested in feedback on that and to see like how far we can push this like merging of DSP and machine learning.
I was gonna just like say there, like the kind of the scenario where you mentioned about the Adobe sort of denoising, where it kind of creates these like interesting effects if you don't use speech.
Mm-hmm.
That's it's super cool to me, because I'm always like interested in like the misuse of the technologies as well, and like what that can create just by like happy accident. Um, but I'm curious, like, whether has there been any like kind of edge cases or like anything with your particular solution that you've it's kind of, I don't know, created something unexpected like that you've noticed? Is there any, I know this is like sort of picking at like, where there might be error in your system, but like has there been anything that's like emerged that you went, oh, that's kind of interesting. It doesn't work maybe so great on that material, or would you say it's been pretty universal?
Well, yeah, I mean, we definitely haven't fully solved everything to do with noise reduction, that's for sure. I think the biggest caveat to mention with our system is that, unlike these big deep learning models for speech enhancement, we're not trying to, you know, if you're going to the middle of Times Square and making a recording of your acoustic guitar, we're not trying to enhance that and make it sound as if you're in a studio, because that in some sense really isn't even noise reduction, in my opinion. It's more like a resynthesis or a reimagining of something that wasn't even recorded fully. Because as the one way to look at it is that as a recording becomes more and more degraded, there's like a loss of information of the original source that you want, because it's getting covered by noise or other interfering sources. So in order to kind of denoise or enhance those recordings, you actually have to invent some information that wasn't there in the original recording after some threshold. And I think that's definitely an area for future research, and there has been some work on that, of like, if you have these super distorted recordings, can you make them sound better? But we weren't really interested in that. We were saying like, I already have a good sounding recording, it just has a little bit of noise in there. And that's actually a really common use case for anyone that's like set up a condenser mic just in their room and started recording. They'd notice like all of this just like ambient noise that they're capturing. And we wanted to tackle that because we knew that we could decrease that noise without harming the original signal in a way. So basically, for those types of cases where you have a good recording, it just has some noise, I think we really provide a good solution to that. But yeah, we definitely, if you want to put in like some super distorted recording, or like you recorded a concert from the back of the hall or something like that, and you want it to sound like hi-fi, we're not going to solve that problem right now for sure.
So would you say your solution is more kind of that subtractive approach then? Like it's not there's not doing any sort of additive kind of reimagining of the sounds at all, would you say?
Exactly, yeah.
Yeah.
So it's purely kind of a filtering based approach, and we use some gates and filters that are kind of based on traditional DSP. The difference
Hmm.
is that just that we use a neural network to dynamically control those settings, actually in a way that would be probably more advanced than a human user could do it themselves potentially.
Oh, yeah, that's super cool. Um, yeah, because I know that like you were mentioning, there's a few companies that have kind of been creating some software that can go from like a kind of um you've recorded something through your phone kind of microphone, and then it's like taking it to like a really high professional grade like condenser mic kind of sound. So there obviously is a use case as well for that kind of reimagining the sound and making it sort of pro quality or something like that. But yeah, it's also interesting. Like I think these some of these models that do reimagine the sound, it's like at that point, at what point does it perceptually become something different? Like it becomes a different like it's not your sound anymore, it's something else. I think that's also quite an interesting
Yeah.
thing to think about. But that's no, it sounds really cool. And you said it's available at
Yeah.
tape.it. Yeah,
Tape.it/denoiser. Yeah. And it's freely
nice.
available. You can just literally like drag and drop any audio file into it and it will wait a few seconds and it'll denoise it. We also, the other cool aspect of our algorithm is it has some level of controllability. So we kind of have this like strength slider and you can move that back and forth in the UI and it will actually change what the denoiser is doing. It's not a wet dry mix. It's actually a bit more complicated than that. So the system
Hmm.
actually has the ability to kind of be more or less aggressive, which we find is really useful too, because sometimes people are like, I want it to sound super dry, or I want it to leave some of the kind of natural ambience in there.
Yeah, and that method that you just highlighted, is that based on like conditioning, like model conditioning for that parameter, or?
It's actually because since underlying all of the processing that's being done of the audio is happening by DSP, we
Hmm.
kind of can tweak those parameters after the model makes its
Ah, I
prediction.
see.
So we can kind of, that's the really cool thing about our approach is that we kind of can put guardrails also on the system. So we can tell it, for example, don't act too aggressively in these cases by setting different parameters and stuff like that. So
Right.
the neural network will never be able to like have full reign of the audio, which is like it's what makes them very powerful for these other like reimagining use cases, but it's also what leads them to add artifacts or like you get that effect of like when someone's in like a big hall and you enhance their voice, it will remove the reverb, but you hear it like kind of chopping off the end just very aggressively, which you can hear a lot of the time. So we can actually tune our system so it won't do that kind of thing.
Right. Super cool.
So for a novice like myself, you were saying that you were using a neural network rather than deep learning. As a person who studied a little bit of neural networks, those two terms have been kind of maybe synonymous to me, but it sounds like there's a difference to you. Can you tell me a little bit about the difference between those and also a little bit about the technique that you use to actually train the model if you can?
Yeah. So I think on the first part, we are using deep learning to do this. The difference is where we use deep learning. So the existing approaches for doing these big speech enhancement models, they use deep learning not only to analyze the recording, but also to process it, right? So they actually like are processing the audio sample by sample with a giant neural network that's predicting the clean speech. Um, Whereas the difference with our approach is we use a deep learning system only to analyze the audio. And then we use that analysis to use a neural network that intelligently predicts parameters for a fully standalone DSP based noise reduction system that we built. So what that means is that when we run our algorithm, there's actually these kind of like two parallel pathways, like the analysis and the actual like processing pathway. And we can operate them independently, or we can, like I was saying before, kind of get into the middle between the neural network and the other device and make any kind of manipulations or put guardrails and things like that. And that not only does it help us with kind of reducing artifacts, but it also helps us with efficiency because we can implement that DSP in like super optimized C++ code that can run in real time. And it's fully independent in its like way that it runs from the neural network. So for example, if we wanted to run this thing in real time, we wouldn't have to run the neural network like on the audio thread, for example, right? Because we could actually run it on a separate thread, and it could be predicting parameters for this DSP thing, and the DSP is running on its audio thread as it normally would, and it could actually be somewhat asynchronous potentially as well. So that's kind of the other big difference of our approach of how we're using deep learning here.
And what about the training itself? What was the process for that?
Yeah, so I don't want to get into too much detail, not because I can't share, but just because it gets very technical. And I would definitely recommend anyone to check out our paper. We can share a link to it as well. It's on archive. But if you're really interested in the details. But to give you kind of a starting point and a high level way to think about it, the approach that we focus on uses something called differentiable signal processing. And actually, my PhD research has focused a lot on trying to understand the different techniques and develop methods for this. And the idea here, right, when you train a neural network is you use something called backpropagation to train the system, right? So you have a neural network, it has a bunch of weights, and you need to optimize those weights. So you set up some training where you make a prediction, you compute the error, and that error gives you a way to compute a gradient, which is a way to tell you how to update the weights. And to do that, you kind of use this basic idea from calculus of gradients, differentiability, and things like that. So every operation inside this kind of computation graph needs to be differentiable in order to facilitate this training that goes from like the last layer all the way up the backpropagation. So when it comes to controlling audio effects or DSP in general, we want to actually train with the DSP in the loop so that we basically predict some parameters, run the DSP with those parameters with some audio that goes through it. Then we get some audio out and we want to compare that audio out to the target. So like if it's noise reduction, we want to have a clean audio and then the predicted audio from the system and compare them and use that to train the neural network to predict better parameters. But this requires that we have to back propagate through this DSP. And that's where the differentiable signal processing comes in, which is all about proposing methods to make DSP differentiable or approximately differentiable or even approximate the gradients whether they exist or not. So in this particular approach, we use this kind of gradient approximation approach, but we do this kind of special two-stage training in order to make it work. And I can't get into more details just because it will get too technical, but definitely encourage people to check out this differentiable signal processing idea. And there's a number of papers out there if you just search for that.
Amazing. So that's really nice that it focuses on efficiency in the system where you can use it in real time. That's definitely something that's been a big problem space industry wide, being able to use these models and using AI in general in real time. Recently, there's been the Landr Mastering plugin that's come out, which is very interesting. Another real-time system that allows I don't really know how it works, but I'd love to hear your thoughts on how you think it may work and if it uses a similar system or something completely different, and how they were able to get machine learning and neural networks into a plugin.
Yeah, do you want to take that first, Andrew? Maybe you have some thoughts.
Yeah, I mean, I guess it's obviously hard to kind of to know exactly how they're maybe implementing that. It's their own proprietary kind of solution, but from the surface it does resemble like something similar to what Christian's been talking about and been exploring. So probably sort of automated mixing, sort of a sort of idea of having DSP blocks as part of like the mastering chain, and then essentially like training a neural network, deep learning algorithm to deep learning model to essentially fine-tune these high-level parameters of the DSP to sort of I guess match some sort of result. So I mean, I guess like I've not actually experimented with the plugin sort of hands-on, but like I guess from the surface and from kind of the material that's been released so far, it kind of looks like it could possibly be that. But then there's also the option that maybe it's a full kind of end-to-end approach as well, where they've conditioned this sort of deep learning model to I guess improve the sound and a sort of mastering style based on high-level parameters that have kind of been exposed to the user. I mean, at the same time, there's quite a lot of parameters, so maybe that's maybe not the case. I think probably it's more likely that it's trained on parameters of DSP, and that's why it's so efficient as well. I think, as we touched on earlier, one of the problems with working with these end-to-end deep learning algorithms is that a lot of the times it's hard to get them to perform in real time, whereas we have some fantastic solutions already in the land of DSP that are optimized for real-time applications. So, and then there's also that this kind of whole thing about, I think Christian touched on it, like running processing in like a real-time environment as well. And I think deep learning algorithms and AI models have some challenges when trying to deploy them in a real-time environment versus like DSP. Just not just because of the computation, but just how they adapt to different conditions that the DAW may set. Like, for example, some models are trained at certain sample rates, and like so they perform at that sample rate. And if the host application that's in charge of the real-time environment is changing sample rate or even buffer size as well, some of these models work on certain sizes of dimensions to the inputs, and like if these are dynamically set in a DAW, then that may not align well with some of these sort of end-to-end deep learning models. Might require some different resampling techniques or things like that on top of the model for it to work. And the stuff that, for example, we do at Newtone with the Newtone plugin is kind of that kind of approach. So we have like an SDK that's publicly available, that allows you to kind of wrap these deep learning models with essentially like resampling layers and like queuing layers that you don't really need to think about, because we've kind of implemented that for you, that allows to kind of cater for some of these scenarios where you want a model to adapt to different sample rates or different buffer sizes and things. But then that also has some challenges as well, because when you resample, you can introduce like aliasing and artifacts like Christian was talking about earlier, and that can also have challenges. So I think the technique that may be applied with Landr, and that Christian's also exploring, where you're actually learning parameters of DSP, as a really nice solution, I think, to handling some of these problems and having really efficient performing algorithms. So yeah, that from a kind of slight tangent there, but like to bring it back, like that's kind of maybe my guess that what's going on with the new Landr plugin. I don't know, Christian, if you have any more insight or knowledge on how that might be working, but that's just my kind of high level view on it.
Yeah, I definitely agree with a lot of those points. Yeah, and I don't know myself exactly what they're doing, but I think we can guess quite a bit just based on kind of how it seems to be working from the outside. I think one really like important question or thing that we would ask first is like, okay, so Landr has already had a very successful existing web-based AI mastering service. So I think the first thing could be is you could ask is like, okay, is all of the processing and like AI stuff happening solely within the plugin, or is there actually some communication, for example, to the web? Like, do they actually go talk to a server, send your song up there, and then send parameters back to the DAW, for example? And I don't know that for sure yet, but I'm sure you can test it by turning your Wi-Fi off when you're running the plugin and see if it still works. But that can be tricky too now, because there are some plugins that even require you to be connected to Wi-Fi for authorization and things like that. So I think moving forward, this is like an interesting question for plugin developers as well as for users about how much tied to the web are their plugins, right? Because traditionally you could be like on your laptop on an airplane without Wi-Fi and still be using all your plugins. But maybe that is changing if more plugins go cloud, hybrid kind of cloud-based thing. But I think my guess is actually that they don't send to the server, but I haven't tested that myself. But that's really interesting, because then it means that they've been able to like distill their intelligence or their logic, to actually run with inside the plugin. And if I had to guess, I think they probably are using some sort of similar approach to this kind of do some analysis with neural networks and then predict parameters. But it's definitely unclear like exactly what kind of stuff they do, and they haven't publicly really spoken about any of that. And the only link that we have is kind of like research papers that came from the original start of Landr that was at Queen Mary 10, 15 years ago. So we have some of those papers and we can kind of go based on that, but we don't know anything, beyond that as far as what they've been doing lately. I think kind of, if I can say like traditionally what people have thought the Landr approach, kind of how it works, is it's more of this kind of like expert system kind of approach, or like traditional logic AI, where like you can do some high level analysis, like extract the spectrum of the signal and like look at the dynamics and like look at some different statistics basically of your mix. And then you can kind of create some reference template. So you say like, oh, if this song is a jazz song, statistics for the masters of that kind of tend to look like this. So then what we're going to do is use that information to like configure an EQ and configure some dynamics processing so that we can make your mix look like it has statistics that are closer to the reference. And I think even in this new plugin, like a lot of the other tools, mastering tools that are out there, they kind of give you this like three options, like I don't know, a warm classic or punchy traditional or something, these different kinds of like words to describe like maybe three different options. And those are all like matching to different statistics profiles basically. Yeah, and so that's kind of how I'm guessing that these kind of systems are working. But what I'm most interested in for the future, looking at these kinds of platforms, is I still believe that there is significant room for innovation in improvement in the algorithms, because I think this like paradigm of combining the neural networks with the DSP, I mean, I fully believe in that as a path forward for solving these problems. And so far, I think like the level of intelligence that we're putting into the plugins, yeah, hasn't reached its full potential, because this kind of like more basic like matching the statistics is not nearly as powerful as like a neural network that can kind of configure any effects and like make decisions based on analyzing large catalogs of music, for example. I don't think we're there yet, but who knows exactly what Landr has put into their product. But I do believe that kind of general paradigm where we're able to separate like the DSP and the intelligence and like have them interact is like super important for having really high quality like audio products.
Yeah, and another thing that, related to that we're seeing more and more of, I think, is the emergence of all these sort of physical models as well. And I think the interesting thing about a lot of these physical models that I think they have the complication that a lot of them have tons of parameters that you need to tweak, to get a certain sound or behavior. And a lot of these physical models can be really accurate, when you look at the physics, the science, and the mathematics, there. But actually trying to tune all the different parameters that might be, there as part of that algorithm to do the physical model, like to actually tune that by hand is like, sometimes near enough impossible to achieve a desired effect. So I can see also like maybe a similar application where you're applying some of these neural networks, deep learning algorithms, to the tuning of parameters for these physical models as well, which I think is another interesting like application for it. I think we've done well as a society to like create these fantastic algorithms, DSP algorithms to achieve these different effects and outcomes. And there's been a lot of like historic research and modeling some quite advanced non-linear systems, like the voice, for example, and various other things, plate reverbs, like all sorts of things that we've got these quite advanced physical models of, but like actually trying to distill those into high level, like few high level parameters that are easy for a user to navigate is difficult, and also to achieve like a desired quality and result. Like sometimes if you don't have these parameters set in the correct way, like the actual behavior isn't ideal. So like applying neural networks to sort of understand and extract the best tuning of these parameters, I think is a really interesting application as well. And I hope to see more and more of that coming out in the near future as well. So like DSP being tuned by neural networks and physical models being tuned by neural networks as well. I've yet to see maybe an example like the physical modeling. I don't know, Christian, if you're aware of any, but yeah,
Yeah, so definitely there's some work even in our research group. There's David Sudholt is one PhD student in our lab, and his kind of PhD topic is machine learning for physical models. And he has a recent paper that he presented at DAFX, I believe, on that exact topic of controlling physical models with a neural network. So yeah, definitely check that
amazing.
area out of research. I think it's as you were saying, there's not a lot of work there, but I'm definitely foreseeing that also growing, and it's definitely a super clear application, like a great marriage of those two technologies, I think.
Does that mean that that you see a trend that's moving towards where the neural network is a control layer and that we as the user are describing how we want it to sound? So we say to a physical model algorithm, I want it to sound like Christian's voice, and that we give it we give it some model data, and that it automatically tweaks the parameters for us. Is that how that interaction would work?
Yeah, I think so. I think, I guess the other thing that I would want to make clear too about this is I don't think it's a mutually exclusive research direction either. So in other words, to make that clear, it means that I think there is a role for like large end-to-end neural network models that don't use any DSP, but I also think there's a role for using machine learning models to control existing DSP or physical models. It's not like a one or the other kind of thing. It's one where we should really have both, because there definitely is kind of, I would say, the predominant paradigm in neural audio research right now is about these like big giant models that can synthesize any sound by doing any means you want. And there are definitely applications for that, and we should continue that research. But to me, it feels like somewhat unsatisfactory if that was the only branch of the tree of research here, because as Andrew said before, there's like so much existing powerful DSP technology that like when in the right hands can create amazing results. And the thing that really motivates me about that is that like every day there are people using those tools to put out amazing content, whether it's music, but it could also be for film production, video games. Like all of those tools are being used by professionals today to make real things that are impacting people. So it kind of seems obvious to me that like to really get the benefit of AI that we're seeing in other domains, like in language, like ChatGPT and derivatives, to really make that kind of impact that's having happen in audio, we need to integrate machine learning models with these same tools. And it's just something we should be able to do, like, with the right research and with the right ability. So I would say it's not the only paradigm, but it's one where I think that paradigm is lagging behind the other one, where people are chasing the like build a giant model that can synthesize anything.
Yeah, and I should say like I mean, I envision like a future where these technologies like coexist. I think maybe some people are, you know, potentially afraid of a lot of this AI technology like taking over from what we already use and tools that we already have. Um, but I think like as Christian said, like I can imagine all these new technologies that are coming out and ones that are being sort of either powered by deep learning technologies and machine learning, like they should and probably will like coexist and just sort of optimize like what we can currently do and extend and augment what we can already do in different ways. So yeah, I think that's kind of and then something to kind of highlight or stress is that there's this paradigm is like uh, a great paradigm for emphasizing the coexistence of DSP, traditional DSP, and these like big deep learning algorithms that are kind of coming out as well.
So it sounds like the idea is more like a shell that lives around existing DSP, existing plugins that we would be able to intelligently be able to describe a sound, and then it would be able to take this existing DSP and do something interesting with it. Is that right?
Yeah, I think so. And I want to extend that even further because I mean I also agree with Andrew, like yeah, there's gonna be use cases for both of these kinds of things for people across the types of users that are out there. Um, I think even the most powerful way to frame it, and this is kind of how I'm thinking about it, I don't think we're anywhere near close to this, but this is like what I would really envision 5, 10 years from now, which is what we're kind of talking about, of this like kind of highest level AI abstraction layer that's a controller of things, or like a configurator of in some sense. It can, that thing in theory, if smart enough, should be able to configure not just DSP, right? But it could also configure neural networks, because we already have a huge set of, audio neural networks that do a bunch of really interesting things. We talked about the speech enhancement models, right? There's also like stem separation models for music, right? There's also models that can generate sound. So you could also think of those individual models that are neural networks also kind of as DSP boxes, but they just happen to have a neural network inside. So I kind of imagine this future in which there are DSP boxes where one is just a parametric EQ or a clipper or something like that. But alongside it, there also could be a stem separator box. And then now what my configurator is doing is actually saying like, oh, well, when the time is right to use an EQ, I use an EQ. When the time is right to separate stems, I use a neural network to do it, right? That's like the smart way to do it, in my opinion. Like, whereas the other approach would be just like, oh, we just use one giant AI model that can do everything. It relearns and recreates all of DSP and stores it internally in some, opaque way that we can't understand, and it takes a bunch of compute to do it. So like I'm less confident of that being like the real solution, and whereas like the smartest system is the one that uses the simplest tool to get the job done, but it can also not get stuck if there's a hard problem, because it's like, oh, I can use this other machine learning model, but only when I need to.
And I think, I mean, that's obviously what we're seeing. A lot of audio engineers, master engineers, they have that sort of say, right? When they're working with the tools, they're not going to like have this, pipeline of audio effects and just be like, oh, well, I don't know, I'll turn down the distortion like really low, because it's not needed as much. It's like you just you yank that out. It's like, I'm not using distortion for this use case. I don't need that. Or the EQ filtering or the compression, like whatever. Like there's obviously and there's a ton of plugins out there that are kind of and not just plugins, DAWs as well, that allow you to chain effects in different ways and decide what effects are actually appropriate for to achieve a desired sound. So yeah, I think that is definitely a great place to be, if we could have some neural networks and machine learning models that can kind of understand that, like when like maybe be part of like a bigger system with like different effects, and can actually work out when to apply certain effects in certain use cases. I think, yeah, maybe in the next 5-10 years we'll start to see that as well. I just want to like also touch on something that's very related to this as well, and it's kind of getting a lot of buzz around it right now, is the new Synplant 2 plugin that came out, which I think has like actually shown to people like the power of this technology in a way of like fine-tuning synthesizers, fine-tuning oscillators with just the right parameters to achieve some sort of sound like that based on like a reference sound. So you can like throw in like a voice sound, or throw in like anything really, like a sound of a violin or sound of whatever, and this algorithm will essentially like tune the parameters of these oscillators to sound like that. And I think that, I mean, there's that, and the power of that's enormous. But I think what this opens up to people, to artists, to creatives, as well as the stuff that Christian's working on as well, is it allows us as artists to start to like deviate from that result with these high level parameters to achieve something fresh and new as well. So I think that's the great power of a lot of the DSP that we work with, is that we have this high level control, and we can change really these sort of high level characteristics of the sound. And I think the great thing about Synplant 2, for example, is the fact that you can say you throw in like a sound of a choir, or the sound of some acoustic instrument, and this oscillator like tries to best match, or not this oscillator, this synthesizer tries to best match that sound. You can then go into like the DNA, as it's like titled, like of that and start to like tweak and like randomize and like shift and deviate like the parameters to then, you know, achieve a result that's completely fresh. And it could be, you know, based on that initial result. So there's like an essence of that, but it starts to kind of become dissimilar in some way that's kind of just opens up a fresh like, you know, listening experience, I guess, which I think is super exciting as well.
Yeah, there are so many things that I love about Synplant too. I love that it's taken synthesis and it's just turned it on its head and just approached it from a completely different direction. I love that. Hopefully that doesn't mean that we're going to see an onslaught of plant-based plugins. Uh, Another thing that I really love about it is that for a person to use it, it has an interface that is very simple. You just drag and drop a sound, you hit one button, and now you come out with the permutations of other different sounds. But yet you also have that expert level control as well that's underneath the hood. And I think the way that they laid it out is really interesting. It really gives a lot of control, you know, some where somebody could very quickly come up with some interesting textures, something that's completely original. But at the same time, if you're looking for something specific, you can get under the hood and you can really tweak those parameters. I really love it.
Yeah, like I mean, there's so many like new kind of sonic possibilities, like you know, when you're working with that technology, which is really exciting. And I think yeah, it's something you touched on there, Josh, with the fact like how they've communicated that information and that experience as a user is like I think really fresh and interesting. And I think that, you know, maybe it's beyond the scope of this episode, but like another thing is like, you know, what does do these new approaches and technologies sort of open up to the actual creative experience of and the interactive experience as a producer, as a musician working with these tools. Like how do we best communicate what's going on and the processing and the processes. And I think yeah, Synplant 2 did a great job in having this sort of, you know, I hope, like you said, there's not going to just be all these plant-based like tools emerging, but like that metaphor and like and then also the idea of like the DNA, which allows you to go in and have like finer control. I think is really a really interesting take on what's going on there, and like the stemming and branching of like these different variations and stuff like that. I think is really interesting. So, I mean, I'm hoping to see like as you know more of these technologies emerge, like really interesting human computer interactions emerge, which sort of shift us away from the traditional interactions that we're used to with like you know just knobs and sliders and things of like simulating kind of physical hardware from the past. I think there's definitely a place for all of that, but I think yeah, I'm interested to see what other interactions occur as well from some of these technologies. So
Yeah, definitely. I mean, and I think I would pick up on that and saying like my feeling more recently, like seeing kind of how fast the research of AI and related to audio is developing. What I think it's a great time for people that are designers and you know people that like want to work on UI design and things like that. Like it's a great time to innovate in that space because there's this new technology layer that's emerging, but it's really unclear what the right way to present that to the user is. You know, like we were kind of saying with Synplant, like, oh, you want to like have potentially a way to hide all of that complexity, but you also want to be able to dig down when it's appropriate. And that's kind of something I've always thought about, you know, in general with this like general paradigm of controlling DSP. Like you can always have one layer that's like a fully black box abstraction. You just put something in and a bunch of things happen behind the scenes. You don't see it, but you can then dig, if it's DSP, you can dig down and see that and understand it at a lower level. But you could even go as far as to say, is like, well, how many levels is appropriate, right? Like maybe there's a way to design like easy, medium, hard level, right? Like of how many parameters I'm exposing. And obviously in plugin design, this has been a common paradigm as well, because you can, some plugins, you know, do have like a little hidden advanced configuration menu and you can do even more stuff. But I wonder, I'm kind of seeing it as that we're moving like a layer up the stack of abstraction when it comes to DSP. So AI lets us like remove even more parameters. But then there's this question of like, can we have meta parameters, right? So like maybe at the bottom most level is DSP parameters. The top most level is just fully automatic AI system. But maybe there's some middle layer where it's like I can interface with this system with some knob, but the knob isn't DSP. It's actually another conditioning signal to an AI system. And obviously this might sound like really abstract and unclear like what that is. And it's because it doesn't really exist yet. And someone needs to figure out how to build that and research that. So I think I'd love to see more collaboration also like from the HCI research space and the AI audio space, because there's just so many questions to answer there.
Yeah, you bring up a great point in that the interfaces that we've had in as music producers, sound engineers have really hit their threshold in terms of what we can do. I mean, taking a look at Synplant from a more technical user interface standpoint, I could tell that there's a lot more technically, a lot of bespoke graphics and a lot of hand rolling of using maybe Vulkan or Metal or maybe OpenGL to actually display the graphics. One thing that's been frustrating to me as of late is that if we look at what we have in the video game world in terms of Unreal Engine and the possibilities there, 3D worlds, just thousands of objects interacting with each other in real time versus the limitations that we have in the real-time audio world. And I would love to see some enhancements on that. Like you said, there are some really exciting possibilities for UX, UI designers to really go out and start exploring. And I'm hoping that Synplant can serve as a point of inspiration for people to start exploring just beyond oscillators and filter controls. The other thing that I was going to say is that one thing that I thought was far ahead of its time that we had on one of our first audio programmer meetups was this game called Dreams for the PlayStation 4. And I always thought that was going to be where I would like the DAW and where I would like music creation to head towards in the future. If you're not familiar with Dreams, it's this amazing game, and big shout out to Bogdan Vera, who's the audio developer there, who actually did a lot of the DSP and a lot of the work. I think is in raw C, not even C++. And it's this 3D interactive. I don't even know how to describe Dreams. It's just this creative workspace where you can create songs, you can create. I think you can create loads of things. And I just remember watching the music creation portion of that. You had 3D arpeggiators, and you just had these interactive things happening that were just way beyond the scope, years ahead of anything that we're doing in terms of real-time music creation now. I would love for things to head in that direction rather than being stuck with I think there's a world for both of those realities to exist, but that's the area that I'm starting to get excited about. So when we see Synplant 2, I'm thinking, okay, can we have Synplant 2 but with something that's something that's 3D? That would be pretty interesting with abstract parameters. And now you start to get into, okay, well, can we make it into, I don't know, I don't have an idea off the top of my head, but something outside of plants, something that's representative of the sound, but not necessarily technically describing the sound that creators will be able to interact with and create things that haven't been seen or created yet. The next dubstep, maybe.
Yeah, uncovering sort of new genres and stuff. I think that would be what I hope the technology leads to as well. And I think that there's something to be said though about like we're talking about these kind of meta parameters, like these almost like perceptual parameters that we can navigate as human beings, like in our listening experience. And I think there's a lot of great research that's been done from on that side as well, like away from the technical space, like on the listening experience, like perceptual characteristics. And I think there's an argument to be made about like maybe that is potentially more natural to us as human beings and how we interact with audio and music, and maybe machine learning and some of these new technologies will allow us to kind of gravitate more towards working through perceptual parameters rather than these like these sort of lower level technical parameters, which could be interesting as well. And I think we're starting to see some technologies come out with like parameters like that. Like I think it's difficult because there's obviously a level of subjectivity in this area, so it's like a kind of you have to be kind of considerate of that side of it. But I think there's also a lot of space to kind of, I don't know, potentially refine the description of certain sounds perceptually, and maybe that's the direction that we end up going when it comes to like parameter manipulation.
Absolutely. Great. Feels like a good time for us to wrap up now. Yes, thank you, Christian, Andrew, for your time. This is awesome. Once again, if you want to join the community, get in touch with any of us. You can do so on the audio programmer community on Discord. You can join the audioprogrammer.com/community. And we'll be back next month for episode 3. So be sure to join us, subscribe via the platform that you're listening on, and we hope to see you next time.
Thanks, everyone.
Thanks.